On a humid afternoon in May 2013, the sky over central Oklahoma turned the color of a bruised plum. In less than 60 seconds, a slender rope of wind expanded into a monster more than 4 kilometers wide. When you look at a classic tornado, like the one in this photograph, you see a predictable structure, a slender funnel that forms high up in a thunderstorm and stretches down to the ground. But on May 31st, the atmosphere near the city of Reno was cooking something entirely different. The air was loaded with massive amounts of heat energy, rising from the sun-baked plains, colliding with a cold front moving down from the northwest. At the same time, high-speed winds crossing at different altitudes created invisible rolling tubes of air. When the explosive rising heat punched through those tubes, it tilted them vertically. A layer of warm air had been acting like a lid on this boiling pot. At 4:30 p.m., that lid broke. Within 16 minutes, a monstrous supercell, like the anvil-shaped storm shown here, rocketed 15,000 meters into the stratosphere. The conditions were so extreme, they birthed a weather event that researchers tracking it found almost impossible to recognize. The storm would soon claim the lives of the very experts trying to decode its physics. Parked near the storm was a mobile research radar, seen here scanning the dark clouds. Instead of taking 5 minutes to complete a scan like standard weather systems, this unit fired pulses of microwave energy every 2 seconds. That high-speed data captured an anomaly. The rotation didn't descend from the clouds. At 20 meters above the ground, the air was already spinning at tornadic speeds, while the air a kilometer up was still broad and disorganized. The tornado was building from the ground up. Because the rotation started at the surface, it expanded almost instantly. In just 16 minutes, the vortex ballooned outward. It morphed from a narrow column into a massive, screen-filling wedge. Radar measurements clocked the width of those tornadic winds at 4.2 kilometers. That is a vortex of grinding destruction, stretching the entire width of Manhattan Island, from the Hudson to the East River. Waiting to see a funnel drop from the sky is the standard trigger for issuing a tornado warning. If the danger is already invisibly churning across the ground, connecting to the clouds later, the sirens will sound long after the destruction has begun. To an observer on the ground looking at the storm in this image, there was no distinct funnel. The base of the cloud had dropped so significantly that it was shrouded entirely in a curtain of rain. It looked like a solid 2.6-mile-wide wall of fog moving across the highway. Inside this massive wedge, the core circulation broke down into a wheel of multiple smaller, intense subvortices, rotating around a common center. Think of a figure skater pulling their arms in to spin faster. The core circulation became unstable, and the angular momentum condensed into tight pillars of wind. Subvortices orbited the center, while tracing chaotic, spirograph-like patterns across the farmland. A vortex might fight the forward motion of the storm and stand perfectly still before violently slingshotting around the southern edge at 290 kilometers per hour relative to the ground. Storm chasers rely on a clear slot of air feeding into the storm, the inflow notch, to safely track on the periphery. But as the El Reno vortex ballooned outward, that pocket of clear air closed up entirely. By hiding its outer edges behind walls of rain and firing out unpredictable subvortices at racing car speeds, the storm turned observation into a deadly trap. Among the researchers tracking the storm that day was Tim Samaras and his Twistex team. They were engineers and scientists, known in the meteorological community for their mathematical precision and absolute caution. Driving parallel to the storm on a gravel road, they were deep inside the inflow jet when the tornado defied its expected southeast path. It hooked sharply north. A subvortex, packing winds near 320 kilometers per hour, swung out from the rain curtain and entirely swallowed their vehicle. Tim, his son Paul, and their partner Carl Young were killed instantly. Alongside several amateur chasers caught in the sudden expansion, they became the first professional storm researchers in history to be killed by a tornado. The Twistex team knew everything there was to know about tornado mechanics. Their loss proved a terrifying reality. Our most sophisticated models and safety protocols are ultimately just approximations against the chaotic extremes of nature. Back in the control rooms, like the one pictured here, forecasters analyzing the mobile radar data found wind speeds inside the subvortices clocking in at an incomprehensible 503 kilometers per hour. That is well into the absolute highest tier of measured wind speeds on Earth. Initially, the National Weather Service gave the storm its maximum rating. But months later, they reversed the decision. The widest and potentially fastest tornado ever recorded was officially downgraded to a severe but lower tier EF3. The enhanced Fujita scale is industry standard, but it is strictly a damage-based metric. As this graphic illustrates, it doesn't matter if your instruments measure 500 km/h winds. The rating depends entirely on finding specific damage indicators on the ground. To earn an EF5 rating, surveyors have to find well-built houses swept cleanly off their foundations, like the suburban devastation seen in this image. But the El Reno monster largely missed populated areas. It ground its way across peaceful stretches of wheat fields and hay bales. Because the fastest subvortices only hit dirt and fences, it couldn't trigger the criteria for an EF5. Classifying extreme weather solely by the human structures it destroys creates a massive scientific blind spot. If we ignore raw radar data because the wind didn't happen to hit a house, we severely underestimate the atmosphere's maximum potential, and that leaves us dangerously prone to underbuilding critical infrastructure for the next time a monster touches down.